Okay, this is 11.6b. So this lesson, we're going to talk about how to take a system and put a matrix to it first. And so that's our first goal. This is the what I would call the coefficient matrix. What I mean by that is if you look at the coefficients, we talked about that before with Cramer's rule. So it's just all the coefficients in front of x, in front of y, those four coefficients. This one right here is the variable matrix. It's the variables, x's and y's. There's two of them, so they're always put vertical from each other. If there were three, it'd be x, y, z, 3 by 1. And then CF is what I would call the constant matrix. And just to prove that this does in fact make this, if we multiply row by column, by the way, this is a 2 by 2 times a 2 by 1, so our result should be a 2 by 1. We get AX, so first times first, plus BY, second times second, equals C. If we multiply the bottom there, we get times this column, we get CX plus DY equals the thing down here, which is F. And so we get that same system, but it's now written as a matrix. So you have to be able to take a system, convert it to a matrix by writing the coefficient times the variable matrix equals the constant matrix. Okay, once you get that, we sometimes use abbreviations for these three matrices. So we call the coefficient matrix A, the variable matrix X, these are capital letters because they're matrices, and B is the constant matrix. And so the goal here is algebraically, can we kind of like solve this for X? Well, if you're in algebra and you see this problem, you go, oh, so easy, just divide by A, we've got our answer, boom, X is B over A. However, whoops, go back. Okay, so however, this is actually not allowed with matrices. So remember, matrices are different than kind of normal math here. So you can't divide by matrix. It's not something we can do. I didn't skip that lesson. We talked about how to add and subtract matrices, how to multiply matrices. We never mentioned division because it's not allowed. So now you know you cannot divide by matrix. So how do you solve this? Well, it's something we kind of learned a while back with functions. So it has to do with this. So that what you would actually do to both sides is you would take the inverse. So I'm going to take the inverse of, I'm going to multiply both sides by the inverse of A. Order is very important in this section. So it's going to be the inverse of A times B. So I'm putting the inverse of A in front and we're multiplying here. And what happens when you multiply a function times its inverse, you probably know this, but you get what's called the identity matrix. So you multiply these two guys, you get I, right? The identity matrix. So you get inverse of A times B over here. And the identity matrix times anything is just whatever that anything is. It's kind of like multiplying by 1. So we finally are able to actually solve this problem. So we get this really fancy method, which if you look at the title, 11.6b, it's called the inverse of A times B method, right? So the inverse of A times B. Remember, A is our coefficient matrix. So the inverse of the coefficient matrix times B, which is our constant matrix. Okay, so all we do to solve a problem is we get our calculator out, and well, let's look at the problem. Here we go. So we're going to get our calculator out, and this is really, I'll write it out just so you have it. So X, which is the variable matrix, equals the inverse of A. So A would be 2, -5, 3, -6. The inverse, the way we write that is we write it to the -1 power. That means the inverse times B, which is the constant matrix. And then we're just going to type that in our calculator, and that should give us the answer. So it's actually a really quick and pretty easy method here. So we're going to type in a 2 by 2, 2, -5, 3, -6, to the power of -1, which means inverse, times a 2 by 1. So let's see, we got to go 2 by 1. So I'm going to customize it. 2 by 1. And that's going to be 15 and 36. Their answer should be, so the variable matrix is 30 and 9. And so I don't want that answer written like that. This is, that's your x, that's your y. So the answer would be 30, comma 9 in parentheses. That's my answer. That's my x and that's my y. If you plugged it in, you can see that it works. So 2 times 30 is 60, minus 45 is 15, 90 minus 54 is 36, and it works, right? So you can always check and make sure your system really does work there. Once you kind of get this, it's not a hard lesson. So use the inverse of A times B. I'll just write it out here. So X would equal, sometimes it helps to write out what you're going to type in your calculator. I do find that is helpful. To the negative 1 power, which means inverse, times the constant matrix, which is 10 and 20. So that's the inverse of A times B. And then you just type this in, right? So 3, 4, 9 to the power of negative 1 times 2 by 1, 10, and 20. And we get an answer of negative 10, comma 10 for x and y. The nice thing about this method, one nice thing besides it being really quick, is this. You can use it on 3 by 3 just as easily, so it works out very nicely. So this would be the constant matrix. There would be a 3 by 3. So I'm just going to go default to 3 by 3. 1, negative 2, negative 4, 2, negative 3, negative 6, and negative 3, 6, and 15. Put that to the power of negative 1 times, I guess this would be a 3 by 1. So 3 by 1. And we get 7, 5, and 0. And so our answer is negative 11, comma, negative 23 is my y, and z is 7. Very fast method. Once you get the hang of it, one more, 2 by 2 here. So it just means you enter a 2 by 2 when you do it. 4, negative 2, 6, negative 3 to the power of negative 1 times, I guess, a 2 by 1 here. So I'm just going to pick it from the list. I guess it's one of our templates, 6, 9. Singular matrix. So I wonder why this made an error here. So we're trying to find the inverse of something. And if you try to find the inverse, remember part of what the calculator is doing when it does this, I believe it needs the determinant. To find the inverse of a 2 by 2, I think the formula is 1 over the determinant times that kind of mixed up matrix. So to determine this one would be negative 12 minus negative 12, which is 0. So if the determinant equals 0, you're going to get something that doesn't work, which means one of two things. So when you get this error message, I don't know if it's no solution or infinite solution. So then you have to think, is this the same exact line or not? Well, that's a 4 to 6 ratio. That's like a 2/3 ratio from 4 to 6. From 2 to 3 is a 2/3 ratio. From 6 to 9 is a 2/3 ratio. I think that is the exact same equation. So this is infinite number of solutions. If these two numbers were different or not in a 2 to 3 ratio like the other, like 2 to 3, like 4 to 6, 2 to 3 ratio, if those numbers were not in that ratio, it would be no solution. So you really have to think about it at this point. Is it the same equation or is it the same slope but different y-intercepts for those two graphs, so to speak? So when you get that error message, it doesn't mean it's no solution necessarily. It could be infinite solution or no solution. You really have to then consider what kind of equations you have. So I try to prepare you for every case. If you're in certain classes, I may require you to do that quiz tonight as well as the homework. It depends on your schedule. You need to look at your syllabus for that. Thanks. Also, might as well do the PSAT. So let's try this one. Go ahead and do it. Stop it and try it. X is the average of M and N. So to average two numbers, you're going to add them up. M and 9, you're going to add them up and divide by 2. That should be X. Y is the average of 2M and 15. So to average those numbers, you're going to add up 2M plus 15 divided by 2 is going to equal Y. And Z is the average of 3M and 18. So if I add up 3M plus 18 divided by 2, I get Z. So then it says I average these three numbers. So if I take these three numbers that I just found, because those are X, Y, and Z essentially, and I add them up and divide by 3, I should have my answer, right? So let's just add these up and divide by 3. So if I add those up, I get a big fraction. That'll be 6M if I add up all the M's plus 24. I think that's 42 all over 2. So that's the total of those. I need to divide that by 3. Does that make sense? Because I'm averaging those three numbers. I added them up and I'm dividing by 3. Let's simplify this first. So this would be 6 times M plus 7 all over 2. So that does simplify. That'd be 3 over 1. So I have 3 times M plus 7 divided by 3. So if I divide this by 3, I'm going to do it that way. Maybe that'd be better. And the 3's cancel and you get M plus 7. So if you got C or D, which are very tempting here, this one you forgot to divide by 2 because all of these were divided by 2. This one you forgot to divide by 3 because to find the average of three numbers, you have to divide by 3. So pretty tough problem there. And that's it for today's lesson.